54 of our student journals. Okay, proving statements about segments and angles. So really we're starting to jump into that proof portion of our book. Started it yesterday a bit. We're going to utilize some of those theorems and postulates we talked about the other day. So remember reflexive. Tell your neighbor an example of the reflexive property.
AB equals AB. What?
Yep. That's right. AB. Yep. Reflexive just says something is congruent to itself. You have the symmetric property. Tell your neighbor a example of the symmetric property.
AB equals BA.
Okay. So reflexive, we have maybe angle A equals angle A. Symmetric, we have angle A, or let's not use angle there, better yet. Segment, AB is equal to segment. Good. Okay. Go with transitive. Thank you. Transitive property. Go ahead and give your neighbor an example there.
If, no, that's not if. Transitive. Oh, yeah.
Okay, can I get someone to give me an example? Yes, Jeremiah? Okay, so maybe angles here. If angle A equals angle B, and angle B equals angle C, then angle A equals angle C. Good? Transitive property. All right. Well, and we have the angle addition property, where if you say two angles make a third, okay, angle 1 and angle 2. If you had a big angle here, angle addition property, you'd say 1 and 2, 2. Angle 1 and angle 2 combine to make angle A. That's angle addition property. We have distributive property. We have associative property. We have segment addition property. We're saying two smaller segments make up the bigger segment when you add them together. If you think of the segment addition, it's kind of the same. Say, hey, if that's A, B, and C, AB plus BC equals AC. Okay. All these different properties we talked about, I haven't even hit on all of them. You're going to start using more and more. Okay. A lot of these properties and postulates are found in the back of your textbook as well. So once you grab a textbook, grab a geometry book in front of you there, find that. And if you look in the back of the geometry book, there are all those pages in the back. You know, they have answers. If you didn't know, there are like answers in the back of the book. Okay, some of you already know this. Okay, but usually somewhere in the back, past you have your index, you have your English-Spanish dictionary. But if you get past all that, there's this page that it's on page A99 on mine. It says the ruler postulate. It has all the postulates and theorems that we cover throughout the year. So rather than having to locate them all, they're in your book as well. And then your properties, addition property of equality, multiplication, reflexive, transitive, reflexive property of congruent, all these different properties we talk about are here as well. So great resource for you. All right? Any questions there? It's a good page to look at, especially while you're doing today's exploration. All right, so there we go. Exploration 1. I want you to work with your groupie. Okay? Spend a couple of minutes on that. What we got for A, we're saying AC equals AB plus AB. That is what? Brennan? Addition, property, equality. No. Yeah. It's not substitution. I'm looking right here. That's given. Okay. So just so that we're clear, always look for your given statements first. A lot of times they're not going to write them for you like this. That's a given. Okay. So now if we go here, AB plus BC, so we're saying this plus that equals that. What do we got? Yes, Nathan? What, that would not be the transitive, no. So if we're saying this little piece plus this little piece equals this big piece. Carson? That is called our segment addition. And I'm going to start abbreviating a bit. Postulate. All right. So if you're forgetting some of these, they might be things to highlight so you study them later on. Okay? All right, Moonty, you got to take out your secret agent. There you go. Just even the other one. There you go. They're like nice little. It's like bling, you know. Danica, letter number 3. Substitution. Okay, now some of you would call that substitution. We also call it the transitive property in this case. So I look at it, and in fact, on my answer key, I've written down substitution and transitive property. So Danica's saying, look, I think she's saying this was AC in this statement, and this was AC in this statement. So am I quoting you correct here? And therefore, AC equals AC, which means this equals that. Okay, that is substitution. We've used that in algebra a lot, but it's also called the transitive property. Yeah? One or the other would be fine with me. Okay? Transitive property there. I prefer you use transitive property because that's what we're working with right now, but if you use substitution, I wouldn't mark it wrong. Okay? And the last one, AB equals AC. Or excuse me, BC. What are they doing to get... Oh, that's special. Okay? What are they doing to get rid of the AB on both sides? Noti? Yeah, they're subtracting. So that's the subtraction prop of equality.
Do we always have to write property of equality, or can we just write subtraction?
No, you got to write subtraction property of equality, but you could abbreviate. You could say sub, or you could say minus prop of equality. You know, if you wrote minus POE, I would be fine with that. Not principles of engineering, but property of equality. That's fine. Okay. If you guys are doing a standardized test, though, like you're taking your SBA test in high school, I would write it out, man. Okay. All right. You guys, any questions on that? This next one's a bit tougher just because it's split between 2 pages. So Exploration 2, in your book at least, if you have your book in front of you, it's on, like your pages are side by side, so you can look at it that way. But that's kind of the one we're doing there. Number 2, Exploration 2. Okay, continues on to the next page. I want you to go ahead and work with your groupies. Do your best to write on that one. Okay, I got to move that so I can focus, and then I'll move it back. Which didn't help much, but that's okay. So let's get you and your groupies. Come on up here. Put up the answers for Exploration 2, and then we'll go through them. All right? Here you go. Not everyone at once. Slow down.
No, you took it. That's mean.
I am mean. I know.
Now, don't change your answer if your answer doesn't appear up there. It just mean that do number 4. That's all right. I see how it is. Okay. Hey, number 1. Measure of angle 1 and angle 3 are congruent. And looks like that's our given statement. Or they're equal. Number 2, they have angle addition postulate. They're saying EBA is made up of 2 and 3, which is true. EBA is made up of 2 and 1.
I can't see it.
Okay. EBA is made up of 2 and 1 based on, we know that angle 3 actually equals 1, so we could substitute that in right there to get 2 plus 1. Okay, which means EBA equals, what does EBA equal?
Measure of angle 2 plus measure of angle 3.
We got it right here.
Oh, what?
Actually, Drew? Yeah, no. You guys, it's kind of a redundant statement. All they're doing is switching this around. It says commutative property of addition, which just means you're adding in any order. So really, this is just saying measure of angle 1 plus measure of angle 2. Yeah, I don't know if it's a necessary step there. Okay? But I guess if you're being really precise on it, because now you can say 1 plus 2 equals 2 plus 3, because we know EBA equals EBA. Right? Therefore, 2 plus 3 is equal to 1 plus 2. That's using, actually, no, we wouldn't want to put that there. They're using angle addition postulate, so let's not use that statement. 1 and 2 make up what? Angle CBD, yeah. That's what we have there. Measure of angle CBD. Okay? And we're just basing that on here. The other statement was a true statement. It's just that's not the reason they gave. But now we know that EBA is equal to CBD based on the transitive property. We know if EBA equals 1 plus 2 and CBD equals 1 plus 2, transitive property, you can say EBA equals CBD. Remember, you always have to end with what they're telling you to prove. That should always be your last statement. Okay, and I like to end my proofs by putting a little thing at the end. Mine's ZDD. Has anyone come up with theirs yet?
Why do you have to have that?
You have your. I don't want to know them yet, but have you figured out what it is yet, man?
Why do you know?
It just tells me you're done with the proof. You didn't just like get distracted and move on to something. Like you could put whatever you want. Like the Greeks, they put QED. Like it is proven.
Does it have to be?
Mine's ZDD. You think it's cool? Yeah. Well, yeah, they're cool if they stand for something. Mine stands for something. I'm not going to tell you what. Carlo? Oh. Like why? Just so I know you're done. I don't know. What does it stand for? I want you to figure it out. I'm having you guess, dude. That's the joy in it. Trying to figure out what mine stands for there.
If we guess it, will you tell us?
If you guess it, I may even give you a dum-dum. Like the first person, I guess.
Is it related to like you personally, or is it related to
no,
that?
not really.
So it's related to that?
No, not at all.
How is that possible?
Okay, you can tell me later. All right, moving on. It is possible. Just don't. I'm all about irritating and confusing Maddie. Okay. All right. Yes. Here we go. This is your student journal, page 56. It just kind of references some of those properties we've talked about. Really what I want you to start doing is working through your extra practice right now. Okay? Extra practice, page 57 and 58. Now, let me point out, we haven't actually talked about the parts of a proof yet. But if you look at the top of page 57, it says writing a 2-column proof. In a 2-column proof, you generally have a diagram. You don't have to copy it if they give it to you. Now, if you're working in a textbook, I don't expect you to tear the page out of the textbook and like put it on your paper. You'd then copy it. But usually there's a given statement if they have given information and telling you what to prove. This is how you end your proof. Notice the last statement here should be what they're saying to prove. Those two pieces always go together there. Make sure that this matches that. Okay? Notice within your proof, you should always list your given information. I usually list it at the very beginning. Not everyone does. Okay, some people list it as they use it, but I list it. I usually list all my givens at the very beginning of the proof. Okay, statements are based on facts that we know or conclusions we can deduct from reasoning, and then we use our reasons. Those are definitions, postulates, theorems that we've had, okay, or statements that we're able to deduct based upon previous proven things. Okay? Please number them. 1 goes with 1, 2 goes with 2. Number them. If you don't, then you can't. I don't know what's going with what. Okay. There are multiple ways to prove things. There's flow proofs, paragraph proofs. We're going to use 2 columns primarily in here. Okay? So, I want you to work with your groupies. Complete page 57, number 1. Here in a few minutes, I'm going to stop you there. If you're waiting for us as a class to discuss it, I want you to go on to 2, and so on, 3, 4, and 5. Okay? Off you go.
I think I understand, but I'm not sure.
You don't have any wheels? Oh.
If I have wheels.
All right. Let's check it out then. Line K and line L bisect each other at point, bisect each other at point M. BM is congruent to CM. Okay. So, first one they give you, right? It's given. Okay? So, a lot of times as you're going through these, just writing out what you actually have, what they've listed for you, will help you out, and actually putting it in your diagram helps out quite a bit. All right? So, if I go to CM is congruent to DM, well, they're saying this is congruent to that. How do I know that? They tell us BM is congruent to, well, let's at least write this. That is congruent to that. They give us that, so we're going to mark that in our picture. CM to DM. So let's break it down. Let's just say, all right, we're right here.
Symmetric property.
Sam? How do we know that CM equals DM, though? You guys, there's one thing that they've done in this proof that there's one thing they have not put in here. They put part of their given statement. They did not put this portion of their given statement. That's a key piece. Okay? So really, we should probably add that line. So K and L bisect at M. Okay, because when we say 2 things bisect each other, what's the word bisect mean? Carlo? Cuts it in half, right? So if K bisects L, it means it cuts L in half. Now, technically it can't cut line L in half, but it could cut this segment in half, implying that AM is congruent to, come on, I don't want to just give it to you. Come on, man. AM is congruent to BM. This is congruent to that. Okay? We know that. So tell your neighbor what else you can come up with based upon bisecting there. All right, what else can we come up with now based upon that? Come on, man. Alex? Good. CM is congruent to MD because definition of a bisector. CM is congruent to DM by definition of segment bisector. Now you'll notice I use different colored lines in there, different colored markings, because we're saying a few different statements here. All right? We know that BM is congruent to DM now, so this is congruent to that. How do we know that? Monty? Transitive property. Yeah, we're saying BM, this right here, is congruent to CM. We're then saying CM is congruent to dm, therefore bm is congruent to dm, based upon transitive property. Okay? bm equals dm. Well, isn't that what they just said here? What's the difference in what they said? KJ? Yeah, one says congruent, the other one says equal. Really what that is, it's just saying that that's the definition of congruent segments. By the definition of congruent segments, you can say that this is equal to that. That's getting really kind of picky there. I would probably be okay if you just did one or the other. Okay. All right. So now we know BM, and I'm going to start highlighting some of this to make it a little easier. BM is congruent to DM. They're equal. Based on the segment addition postulate, what do we know? Yeah. Good. AB equals AM plus BM. Okay, so AB is equal to this plus that. All right? So look at your reasons and think about what the segment addition means. It means you're adding two things together. And now AB equals AM plus DM. So AB, so this length is equal to AM, which we just had up here. But now we don't have BM anymore, we have DM. How did they get BM to become DM? Sam? What's that? Yeah, they're equal. So what are we using there? Danica? Yeah, you're using substitution there. You're just saying, hey, I know that BM equals DM. Therefore, wherever I see BM, I could put DM. Okay. Substitution. You're just substituting this piece in for that right there. Drew? Huh? You thought it was approved? I didn't catch. How is it approved? Yeah, they're asking you to prove that. So by going through these steps, you've actually proven that that's true. Okay, Alex?
So, for substitution on 6
Uh-huh.
and transitive property on 3, are they the same thing?
Yeah, substitution and transitive property, a lot of times, they go interchangeably. You can kind of think of it that way. You would actually have to use substitution twice usually when using transitive property, but they a lot of times get used interchangeably. Here you're not actually using the transitive property, right? Because here you're saying BM equals DM. You're not saying BM equals something here. And you're not saying DM equals something here. Okay, you're using straight substitution there. Okay? It'll become more clear the more you use it, okay? And just keep asking. All right, now I'm going to end my proof, ZDD. You get one guess. Anyone want to guess? Carlo? Nope. All right, moving on. Number 2. Nope, get one guess. Get another guess later. Number 2, give it a go if you haven't done so already. Start it up. This is on page 58 of your student journal. Angle AEB is complement to BEC. That is given. All right, I helped you out there. Okay? Number 2, angle AED equals 90 degrees. What do you think there, Drew? What's that? So definition of complementary, you're saying this is angle AEC. Okay? Tell your neighbors what you think. Will that work out? Got to come up with a reason. Some of you said, I'm not done. Well,
AEB plus BEC equals 90 degrees.
Well, the thing is, we don't know because there's no right answer.
What is wrong? This is like not possible, right?
it is possible.
I hate proofs.
You hate proofs already?
Yeah.
All right. Hey, so usually when we have complementary angles, we're talking about we're talking about multiple angles. So which two angles make complementary angles based upon this statement up here? Moonty? Which two angles? Good. Measure of angle AEB plus measure of angle BEC equals 90 degrees. Why? Because by definition of complementary angles. So here they're saying, hey, this is the complement of that. Therefore, that plus that equals 90. Okay? Sometimes you're like, well, yeah, duh. I mean, it's complementary angles. They add up to 90. Well, yep, you have to state the does when you're doing proofs. You don't actually write duh, unless that's your ending. Duh. Okay? Maybe you write duh as your ending. All right, number 3. Quickly, tell your neighbor what you got, or what you think if you don't have anything. AC. We've used it before today, or something similar. Okay, what do we got? We got AEC is saying it's made up of this angle and this angle. When we're saying two things are made, the whole is made up of two parts, what are we using? Come on, take a guess. Yeah? Angle addition postulate.
Oh, yeah.
Angle addition postulate. Maggie's like, I love proofs.
I hate proofs.
Okay. Angle addition postulate. How many thought that? How many actually said it to your neighbor? How many said it inside your head? You guys are talking to yourself. That's kind of scary. Okay. AEC equals 90 degrees. All right. Does it equal 90? Yeah, it's like, well, didn't we just say that up here? No, we actually never said it. How do we know it's equal to 90? Isaac? Yeah, because AEB equals AEC. AED. We're not at AED yet. We're just at AEC. Carla? I think you might be getting ahead. Carla? Okay, AEB plus BEC are complementary and they equal 90. How do we know this equals 90? Yeah?
Because AEB plus BEC equals 90 degrees.
Yeah,
and AEC equals AEB and BEC.
Very good. So look at this. We know that AEC equals that. We also know that this highlighted yellow thing equals that. Therefore, this equals that. What property is that? That is the transitive. Guys, I promise it'll get easier the more you do them. I know they're frustrating and weird right now. They will get easier.
It broke.
Yeah, thank goodness. Yeah. All right. AED plus AEC equals 180. Definition of supplementary. It makes a straight line. We can always assume a straight line there. Substitution. Drew? Okay, so AED, you could substitute kind of AEC. So what do you want? What else are you putting here? I don't think I'm following. Say it one more time.
So AEC
Yep.
is equal to AEB and BEC.
Correct.
So can you substitute AEC in number 5?
Yep.
For AEB and BEC?
So you're saying take this and put it in right here? We could. That's not what we're going to do there, though. But we could substitute those. Yeah. You're close. Yep.
Measure of angle AED equals measure of angle AEC.
We don't know that those are equal. Yeah. 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 So you could say, hey, look, we know that AEC equals 90. Right? So you can just plug that 90 in right there. So AED plus 90 equals 180. That's the substitution we're using. So we're just following that step, that process there. This last one, AED equals 90. How are we getting that this equals 90? In other words, how did we get rid of that 90? Yeah, subtraction, property of equality. All right. What do you guys think? Dun 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 dun.
I don't understand this.
I'm loving it. Is it easy?
No.
Oh. Yeah. Jeez. Well, you know, I could really make you upset and say prove it. But you say it's difficult. It's not fun. That's kind of funny myself. All right, number 3. If RST equals TSU and TSU equals VWX, then RST equals VWX. Tell your neighbor what property that is.
I don't care.
You do too care. That equals that. Notice the middle is the same, therefore it is transitive. Okay, number 4. If GH is congruent to JK, JK is congruent to GH. What's that? Starts with an S? Symmetric. Don't you guys just, I mean, like, aren't you just yearning for those days of just those? You're like, oh, those problems were so easy yesterday. Man, now we have to do this lame number 5. Write a 2-column proof. They don't even tell me anything. They just give me like a T-chart. That's ridiculous. That means I have to list all this junk? Yeah. You are now a big kid. You have graduated to this fun stuff. Oh, yeah, way.
Teacher fun or student fun?
Yeah, just
We're
fun.
moving too fast.
I know, fun. All right, so your assignment tonight is number 5. You must write a whole proof on your own. Yeah, some of you are like, dude, that's a piece of cake. You're right, it is. It's like a little piece of cake. It's like a cupcake, but you're going to do it. Okay? All right, there you go.